Welcome all. Today we are going to discuss about oscillations and waves. I am Dr. J. Selvi, working as an assistant professor in the Department of Physics, Fatima College, Madurai. So first let's see about what is called motion. Motion is when an object changes its position with respect to a reference point in a given time. There are different types of motions in our real life are rectilinear motion. That means a particle moves in a straight line. Examples marching past of students in a straight line, an apple that falls freely in vertical direction under the influence of gravity. Next types of motion is periodic motion, a motion that repeats itself at regular intervals of time is called periodic motion. Then oscillations is of a motion is the movement of to and fro motion about a mean position called an equilibrium position. It is periodic motion that it repeats at regular intervals of time, and oscillatory motions are also periodic, but all periodic motions need not be an oscillatory motion. Oscillations and vibrations are essentially the same. The low frequency periodic motions are called it as an oscillation. Example as oscillation of a pendulum. High frequency periodic motions are called as vibrations, that is vibration of a string of a guitar. Periodic motions which can be represented by a sinusoidal wave, the sine or a cosine wave are known as harmonic motion. Simple harmonic motion is a special type of periodic motion with some unique characteristics like the motion is periodic about an equilibrium position. Restoring force should be proportional to its displacement from equilibrium directed towards the equilibrium point. There are two types of simple harmonic motions are there. One is a mass spring system and the other one is a pendulum. The definition for a simple harmonic motion is a periodic motion which occurs in mechanical system. In simple harmonic motion, the net force acting on the object is proportional to the displacement of that object from its equilibrium position, and the force is always directed towards the equilibrium position. In order for nuclear mechanical oscillation to occur, a system must possesses two qualities. One is it should have the elastic nature and the other one is an inertia. When the system is displaced from its equilibrium position, the elasticity provides a restoring force such that the system tries to retain to equilibrium. The inertia properties causes the system to overshoot equilibrium. This action between the elastic and inertia properties causes oscillatory motion. Therefore, the natural frequency of the oscillation is related to the elastic and inertia properties of the material. The diagram shows the one which I have explained now. The examples of spring mass system is an oscillating system is a mass connected to a rigid foundation with a spring. The spring constant K provides the elastic restoring force and the inertia of the mass M provides the overshoot. The time period, the time taken by the system to return to the starting point after one complete cycle of motion, or it is called it as one oscillation. T is equal to 2 pi by omega naught, or 2 pi is equal to 2 pi. T is equal to 2 pi root of m by k. Velocity is given by v of t is equal to minus omega naught xm sine of omega t plus phi. Acceleration is given by alpha t is equal to minus omega square xm cos of omega t plus phi. Velocity and acceleration in simple harmonic motion. In simple harmonic motion is a projection of uniform circular motion on a diameter of the circle in which the later motion takes place. Circular motion is the one of uniform circular motion projected in one dimension in simple harmonic motion. That is the ball mounted on a turntable moves in uniform circular motion and its shadow projecting on a moving strip of film executes a simple harmonic motion. A simple pendulum is nothing but an object hanging from the end of the string or rigid rod, pivoted about the point. The object is displayed about a small displacement that is about 5 to 10 degree to one side and allowed to oscillate. If the object has negligible size and the string or rod is massless, then the pendulum is called a simple pendulum. Damped oscillation. A simplest case is when the damping force is proportional to the velocity of the oscillating object. What is called as wave is nothing but a disturbance or a variation that transfers energy progressively from point to point in a medium. Wave may propagate through a medium by a elastic deformation. It may also propagate as variation of pressure, electric potential, temperature or more. There are different types of waves out there. One is a mechanical wave, regulates a medium for propagation, governed by Newton's laws, example water waves, sound waves, and seismic waves. Next type is electromagnetic waves, do not require any medium for their propagation. Example visible and ultraviolet light rays, light waves, and radio waves, microwaves, etc. Matter waves are the waves associated with the motion of a particle of atomic or subatomic size, that is, electrons, protons, neutrons, other fundamental particles, and even atoms and molecules. Then let's say about what is transverse wave and longitudinal wave. Transverse wave is when the particles of the medium vibrate perpendicular to the direction of propagation of wave. It is called transverse wave. A longitudinal wave is a wave in which the particles of the medium vibrate in the same direction in which the wave is propagating is called a longitudinal wave. There are different wave parameters. Amplitude is half the height difference between a peak and a trough. Wavelength is a distance between the successive peaks or troughs. Period T is a time between successive peaks or troughs. And frequency measures the number of peaks or troughs that pass per second. A wave is a disturbance that travels from one location to another, and it's described by a wave function that is a function of both space and time. If the wave function was sine function, then the wave would be experienced by y is equal to a sine omega t plus or minus kx. A negative sign here is used for wave propagation along positive x direction, and the positive sign is used for the wave propagating in a negative x direction. Wave velocity, it's nothing but it depends on the medium through which the wave moves, related to the wavelength and frequency. And there are this are the points which is for the interaction of matters and waves. Waves can travel from one medium to another, undergo reflection, diffraction, and absorption. The speed of waves depend on the elastic properties of the medium through which it travels. When a wave encounters different medium where the wave velocity is different, the wave will change directions. Sound waves traveling through different medium undergoes a change in speed. When waves approach a shore with a gradual depth profile, example in beach or most of the wave energy is absorbed by the breaking of waves. When waves approach a hard vertical surface, that is when it reaches a concrete wall or a dock, most of the energy is converted into waves moving in an opposite direction, that is a reflection. Of course, the reflected waves are superimposed on the original waves. The principle of superposition may be applied to waves whenever two or more waves traveling through the same direction, medium at the same time, the wave pass through each other without being disturbed. The net displacement of the medium at any point in space or time is simply the sum of the individual wave displacements. Reflection of waves. When a wave encounters a boundary, it will reflect back. That is reflection. The wave in which it reflects will vary depend on whether it encounters a fixed or a free boundary. Fixed boundary is a one where wave encounters a fixed surface. Free boundary is a one when a rope is attached to a post and it's free to move up and down at the end, that is called as free boundary. Reflection is waves bounces back of a surface that they encounter. A travel wave at a rigid boundary or a closed end is reflected